The slides are coming, but I can already introduce the next speaker. He is Monty, and he's going to talk about cross-chain mitigative safety mechanism.
Yeah, so I mean, I'm not going to start without the slides because I unfortunately haven't memorized them. But yeah, I'm Monty. There you go. Yeah, thank you. So today we're going to talk about mitigative measures for breach exploits. And yeah, a bit about me. I'm Monty, co-founder of Range. I've been working in crypto for about 5 years and specialized in security for the last 3, and it's particular in the Cosmos ecosystem. So yeah, today we are going to talk a bit about breach exploits, mitigative mechanisms, with an emphasis in Cosmos. So why breaches get hacked? I guess the first one is breaches handle a lot of TVL. So, you know, like they are like very good targets just for attackers. Like the attackers mostly are rational economic actors. So yeah, bridges are very targeted for that. Some designs are better than others in bridges, more on that later. And bridges are very complex. Sometimes they have to integrate many different blockchains. They have to be written in different languages, so end up being even more complex than the blockchains that they are integrated with. So like this is a really nice anatomy of bridges by types of design from LiFi. You can see in the blue, like in the very left, the most trusted designs, like these are multi-sigs, and then as we go to the right, we get to more like trustless designs. In the middle, we have like POS, validator insert systems, and then in the very right, we have what we call trust minimize or trustless designs. One of that we are going to talk later is IBC with light clients and relays, but then we have as well CK bridges, which there says non-exist, but there are many other projects right now building them out. So yeah, like the reality is that all bridge designs are not created equal. I think as a community, like we've made a lot of progress and moving more for like the right side to the pink. So we are building more and using more trust minimize and trustless bridges. But the reality is we are not there yet, as we've seen like in last week and many other events. But we have to understand that most of the breach exploits are not just because the designs are poor. Like if we see, I mean, there are some, like for example, the one in the yellow are multi-sig bridges, so bridges where the key has been compromised, like the big one, of course, is running. But the majority of bridges actually have been implementation flaws, right? So it doesn't really matter the quality of your design, how sound your protocol is. Even the most sound protocol, bridge protocols can be subject for implementation flaws. This is the case for trustless bridges, but this is also the case for canonical bridges between Ethereum and L2s. So we need to assume as an industry that, we like it or not, there will always be yet another software bug. And also, like what we really realize is that as we move more to trust minimize and trustless bridges, they are more complex. Like they are very complex software projects, like for example, at the bleeding edge of CK and distributed systems, so there will always be bugs. We need more proactive and mitigative safety mechanisms. Audits and focus on code is not enough, and also breach code bases are not immutable, so are very large code bases that are really not immutable. And also breaches have a systemic risk to the whole crypto ecosystem. They are really the glue, and they really pose systemic risk for all the applications that talk to. So we need different types of mechanisms and mitigative mechanisms. Some of them are here, like for example, rate limits that we are going to talk later, like IBC rate limits and the recently proposed RC 72881. We have also transaction delays as the one implemented by the Wormhole team with Wormhole Governor, and then circuit breakers, MMA, multi-message aggregators, and also like Hashi by the Gnosis team. So now we are going to step over the pond and go to the Cosmos ecosystem, how we are handling this right now. So for those that don't know, IBC is a trustless protocol, interoperability protocol that communicates arbitrary data between different state machines, initially built for Cosmos, but now these light clients have been ported to other ecosystems like Polkadot and Ethereum. And we have IBC3 Limits, I think, is the first standard on the wild being used in production. So these are governance configurable rate limits for fungible tokens over IBC. This means, as a naive example, that a specific token A cannot be transferred more amount than 100 in the last hour between in or out a certain chain. And this is very important protection mechanism because it's not just protecting that there is implementation flaws at the bridge level, but it's also protecting at the chain itself that the destination is not exploited. So in Cosmos, we talk a lot about sovereignty. So what rate limits gives you is actually sovereignty of how much you trust your counterparties. When you're a chain, when you're a project, and you are connected with another chain, without rate limits, you're actually just giving an open bar. And it's just not the bridge that can be exploited, but also your counterparty. So rate limits give us kind of like parameters to reason about this trade-off space. We have two implementations. The first one's by the Osmosis team, and this is implemented with Cosmos WASM smart contracts, which is a framework written in Rust for Cosmos and compiled to WASM. And then we have the native Cosmos SDK module written by the Stride. And this is just the present. This is in production. This is live. But what is the future looking at for us? So we want to extend as a community beyond like fungible token transfers. As we mentioned before, IBC is arbitrary message passing. So we can pretty much put rate limits in any type of message that happens cross-chain. We would like also to combine rate limits with transaction delaying, as we discussed with Warhol. I think there are many cool features that you can do here. And then also just make them smarter, so make them dynamically adjustable, so you can, based on on-chain events, you can adjust the rate limit of a certain token pair. So you could even say, hey, when an upgrade happens, make like the rate limit very small, and then you can continually increase it as you get more confidence on your implementation. And this is really like our focus that we are putting in range. So we are building in Cosmos, and we are kind of putting layers of security layers on top of IBC, integrating off-chain monitoring systems, and also these on-chain mitigative techniques that we've discussed before, like on-chain mechanisms, like rate limits, circuit breakers, and more. We are range. My Twitter handle is AES Monty in Twitter, and I'm just super excited as well to know how other bridges, other projects are thinking about this and on other on-chain safety mechanisms. So yeah, just reach us over Twitter or here in the conference, like super looking forward to discuss all these topics. And yeah, thank you very much for your attention.
Thank you.